Oh, hello. Don't mind me. I'm just playing around here a little bit. Oh, you want to join? Yeah, come on. I'm just gonna do a little. I chopped up these little pieces of paper here. It's just kind of fun, you know. Every time you breathe, they go everywhere. But anyway, I chopped these up because I'm gonna do a little bit with charge here. Do an introduction to charge. Now I know you guys have heard the whole proton electron thing, and you know that's I get that, but I want us to dig a little bit deeper. I want us to understand how do we even know that there are two different kinds of charges, right? That's going to be our goal right now. It's kind of an introduction. How do we know, right? We can't even see a proton or electron. I mean, don't give me that crud. All right, so let's look. First thing we're going to do is we take this black rod, just everyday black rod. It's not no, it's not magic. Okay, it doesn't have the little white thing on the end. It's just the everyday black ebonite rod. Okay, it doesn't really do anything except I guess if I drop it, maybe things will pop around a little bit. But if I take it and I rub it on my hair, what happens? I know what's gonna happen. Y'all gonna say, "Wow, you crazy man." No, but I'm gonna rub it on my hair just a little bit here. And when I get it close to the paper, you can see that some of them down there are standing up. All right. Oh, I'm gonna try that one more time. Here we go. Rub. See if we can get it rubbed. Unfortunately, I've been rubbing it on my hair a lot today, so I may be all out of electrons. All right. So here we go. And you can see some of them. There you go. They're jumping up just a little bit there. Okay. Not super strong, but there definitely is something happening there. So what we say is that the rod has been charged. Now, what that means, we don't really know, but we do know that something magical has happened to this rod that now allows it to pick up and attract neutrally charged pieces of paper. We say it's neutral because initially nothing happened. It's just kind of normal. It's neutral, right? And so that's why we say it's neutral. The paper and the rod are both neutral. But when I charge the rod, it's now able to pick up those little pieces of neutrally charged paper. All right, let's try this. Now I got a glass rod. I rub it on this piece of fabric. A little bit different. All right. And we put it there. Oh, you see that? Look at that. The glass is attracted too. Well, that's kind of snazzy. So we were able to charge up this glass rod as well. Okay, great. So we know that when we charge something up, the black rod, the glass rod, when we charge it up, it can pick up neutral pieces of paper. But we haven't said anything about there being two different kinds of charge yet. They could both be the same. So how do we know the difference? Now what I've got is I've got this black rod. The black rod right here is hanging from the ceiling. First thing we're going to do is we're going to take that black rod, we're going to charge it up. All right, just like that. Then we're going to take the other one. Oh, I don't want to swing like that. We're going to take the other one. We're going to charge it up too. What happens when they get close to each other? Look at that. See how it's pushing it around? I'm not touching it. Okay, I can maybe even put it on the other side, get it to slow down and go the other direction. You see that? So when they're both exactly the same, it actually repels. It can stop it and get it to turn around and go the other direction. So when they're the same, when they're both charged, they repel, right? Okay. There we go. There's the charge. There's this. And what happens? Whoa. Look at that. It's chasing that glass rod. You see that? I put it on the other side. Oh, there we go. Put it on the other side here. Come on. Put it on the other side. Come on. Ooh, see how fast it's going there? It's actually following it. It's attracted. That's different. All right? Now, let's see if we can put it all together. All right. So what do we get? Let's go over it one more time. All right. First, we charged the black rod. We rubbed it with my hair and put it over those neutral pieces of paper. And what happened? It attracted the neutral paper. Since it was attracted, that's why we said it was charged, right? It had something that now allowed it to pick up the paper that it couldn't do before. We charged the glass rod. We took the glass rod and rubbed it on that piece of fabric. And what happened? It attracted the neutral paper. So we know it was charged. At this point, they could have been both been the same thing, right? They accomplished the same thing. So they could have been exactly the same. But here's the kicker. When I charged the two black rods, what happened? They repelled. Now we know that these were the same, right? These two black rods were exactly the same. I rubbed them both on my hair. They repelled each other because they were the same. So what we learned is that two things that are charged the same way are going to repel each other. But then what happened when we charged the black rod and the glass rod? We noticed that they attract. Why is that important? Well, that's important because we know that they were both charged, right? It's not this idea of, well, it's attracting because the glass is neutral. No, no, no. The glass was charged. The black was also charged. But they can't be the same because if they were the same, they would repel. So what that must means is that there's two different charges. It doesn't necessarily mean opposite, though we later learned that they are actually opposite, but they're definitely two different charges. And when charges are different, they will attract. All right. Now, it wasn't until later that they started putting terms on this, right? It was Benjamin Franklin, really, that started coining the idea of positives and negatives. He said, well, if they're the same, they're both going to be either both positive or they're both negative. And if they're different, one of them is positive, the other's negative. He could have called it up and down if he wanted, right? Two opposites. He could have said, well, this has an up charge, this is a down charge. He could have done cats and dogs. He could have said, this has a dog charge, these are dog charge, and the glass has a cat charge. It doesn't matter. They just need to be different, opposites. Now, mathematically, it's helpful to have positives and negatives, right? Not cats and dogs. And I mean, what do you do with those mathematically? I don't know, other than throw them out the window. I didn't say that. All right. So at this point, really my question now is, so we've already determined that if it's the same, it repels. If it's different, it attracts. What is it about it? Well, you guys know now, at this point in your science lives, you know that an atom is made up of a positively charged nucleus and the negative electrons that are moving on around on the outside. Now, because the nucleus really has to stay where it is unless you're physically moving atoms from one place to another, then really what matters is the electrons. The electrons are the thing that move from one place to another. Those are on the outside of the atom. It's pretty easy to move them across. Those are also we talked about that a little bit in the last unit, how easy it is sometimes to get those electrons to pop off. In this case, it's not living flesh, so it's not a big deal. And your skin can handle having some extra charges and a few less charges as long as it's not too significant, right? So it's really about the electrons. What we know now is that the black rod, when you rub it on the hair, it actually strips electrons off of the hair, making the black rod negative because it has extra electrons that it pulls off of my hair. Okay, the glass rod actually, the glass rod will lose electrons. The fabric will pull the electrons off of the glass, which because it's missing electrons, it will actually become now positive, right? Now, one interesting thing I think we should probably note is this neutral thing, right? How did it pick up something that was neutral? Well, think about this. We've got a black rod. I know my black rod is red. Get over it. It's negatively charged. I have a neutral piece of paper. Now, that neutral piece of paper, usually it's got positives and it's got the negative electrons, right? And those negative electrons are usually kind of arranged around the protons in whatever way. You know, they're just kind of around there. It's pretty evenly distributed. But what happens when I bring this negative rod close? These electrons say, no, 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 I don't want to be over here. I want to be over on the other side. As far away, remember, the same repel. So the negative bar is going to repel those negative electrons. These guys will say, no, 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 I want to get away as far as I can. Far as I can, right? Get away, get away, get away. All of your electrons are going to try to get as far away as you can. Now, that may not seem like a big deal, but it's just enough, because now all of your positives are closer than the negatives, which means that the force between the negative and the positive is stronger than the repelling between the negatives, because the force between them depends on how close they are. All right? Which means that this negative and those positives now attract, and that attraction is stronger than the negatives. And surely you're thinking, yeah, but that's such a small distance, it can't make that big of a difference. Well, if it's just one atom, it doesn't make a big difference. But when we're talking about billions and trillions and quadrillions, and I don't even know what kind of illions of atoms, every little bit makes a difference. And this is what allows your neutral piece of paper, because the positives are now closer, that's what allows that to be attracted. The opposite happens when we put the positives there. The negatives now jump to the other side, and now the negatives are closer, and so the attraction happens. Now recognize the pluses are not moving. The pluses are your atoms. If they were moving, your whole object would deform when you get that charged rod next to it, but that's not happening. Okay, it's just the electrons that are moving around there. All right? That's enough for this video. I think that's a good enough introduction to charge and how charge works. Let's go look at insulators for just a second. All right?